Imagine waking up tomorrow morning and the world is wrong. Not wrong in a way you can immediately explain. The sky is still there, the sun still rises, but something is missing. Something so fundamental, so woven into the fabric of life on Earth that its absence rewrites everything. Every plant on Earth, every blade of grass, every ancient oak, every kelp forest on the ocean floor has lost its chlorophyll. Overnight. Gone. And most people don't even know yet that they're already dead. To understand why this is apocalyptic, we need to understand what chlorophyll actually is. Because this isn't just about color. This is about energy. Chlorophyll is a pigment molecule, a beautifully engineered chemical trap for sunlight. It absorbs red and blue light from the sun and reflects green. That's why plants are green. That reflected green light? That's the leftovers. The light chlorophyll didn't need. But what it does with the light it absorbs is staggering. Using just photons, water drawn up from roots, and carbon dioxide from the air, chlorophyll drives a reaction that produces two things: glucose, pure chemical energy, and oxygen. The oxygen? It gets released as a waste product. The same oxygen filling your lungs right now. Think of chlorophyll as a solar-powered engine at the base of every food chain on Earth. Every calorie you've ever eaten traces back to it. The cow that became your burger? It ate grass. The grass used chlorophyll to build itself out of sunlight. You are, in the most literal sense, made of converted starlight, and chlorophyll is the machine that did the converting. So what happens when you switch off chlorophyll is the machine that did the converting. So what happens when you switch off every engine on the planet simultaneously? The plants don't die instantly. They starve. Without chlorophyll, photosynthesis stops completely. No new glucose is produced. Plants begin consuming their own stored energy reserves, like a person eating their own muscle to survive. Within days, the most vulnerable plants, grasses, small shrubs, crops, begin to wilt and collapse. Farms go first. Wheat, rice, corn, the crops that feed billions, have shallow reserves. They're dead within a week. Supermarket shelves aren't restocked. Somewhere, in government buildings, people begin making very difficult phone calls. Now the animals feel it. Herbivores, the creatures that eat plants directly, find their food supply collapsing beneath them. Cattle on farms have days of feed left, maybe weeks if rationed carefully. Wild herbivores begin mass migrations, following the ghost of an instinct to find food that no longer exists. Starvation spreads across the animal kingdom like a slow tide. The trees are slower. Ancient oaks and redwoods have stored decades' worth of energy in their root systems. They can survive for months, maybe longer, drawing on reserves. But they're not growing. They're not breathing. They're just waiting, like a candle burning down from the inside. With herbivores dying, the carnivores, the wolves, lions, killer whales, eagles, find their prey disappearing. And here's where it gets tragically ironic. The apex predators, the animals we think of as the strongest, are actually the most fragile in this scenario. They're at the top of the food chain, which means they're the furthest from the source of energy. When the bottom collapses, the top falls hardest. The ocean is no different. Phytoplankton, microscopic plants that produce half of Earth's oxygen, are gone. The ocean food chain, which feeds 2 billion people, begins its collapse. The sea goes crystal clear, beautiful, silent, dead. Here's where the atmosphere becomes the story. Earth's oxygen supply isn't infinite, it's a cycle. Plants produce it, animals consume it. Without photosynthesis running, oxygen stops being replenished. CO2, which plants used to absorb, begins accumulating. At current oxygen levels, this takes years to become critical for humans. Our atmosphere has a large buffer. But CO2 buildup is faster. Temperatures begin to rise. The greenhouse effect, already a slow emergency, becomes a rapid one. Weather patterns destabilize. Humanity, to its credit, would adapt, desperately. Greenhouse farming with artificial light, algae bioreactors, synthetic glucose production, food rationing at a global scale never seen before. Of course, this didn't happen. You'll go outside today and the leaves will still be green. The grass will still be growing. The world's engines will still be quietly, invisibly running. But inside every leaf around you, right now, there are hundreds of millions of chlorophyll molecules, each one a nanometer-scale machine, catching photons and turning light into life. They've been doing this for 3.5 billion years, long before animals existed, long before oxygen filled our atmosphere. Chlorophyll didn't just adapt to life on Earth. In a very real sense, it built the conditions that made our kind of life possible at all. We spend a lot of time worrying about the things that could end us: asteroids, pandemics, conflict. But perhaps the most quietly awe-inspiring thing in the world is something so ordinary we don't even think about it. A green leaf, soaking up sunlight, breathing out the air you breathe in, and asking absolutely nothing in return. Take care of the green.